OSU News with 5-time Emmy Award-winning anchor Andrew Pavlovsky. Lauren Malone, co-anchor. Garrett Miskell, weather. And your reporter in the field, Liz Roche. It's OSU News at 6 o'clock.
Good morning, Columbus, and welcome to OSU News. I'm Lauren Malone.
And I'm Andrew Pavlovsky. Today we have a lot of information for you, including a special story from our reporter in the field, Liz Roche.
Our biggest story, however, is the AEV Showcase for Engineering 183 students on OSU's campus. But first we go to Garrett with the weather.
How's it looking out there, Garrett?
Good morning, Columbus. This morning we have a 50% chance of forming with defining the project, getting acquainted, building a team, and setting initial goals. We have a 38% chance of storming with team agreements, creating a plan, setting specific goals, writing a schedule. What do you think, Karen?
Hi, I'm Karen Smith with a weather report today, and it's 86 degrees, and there's a 30% chance that it's already brainstorming.
We have an 86% chance of norming with building teamwork, implementing project design, monitoring progress of goals, building AEV, and writing performance codes, and 100% chance of performing. That is documenting progress, completion of design, editing final codes in AEV design, and presenting final product. This teaches people how to create effective team dynamics through mutual respect, sharing ideas, encouraging others, and compromising. This has been the Weather Report. Back to you, Andrew and Lauren.
Looks like success is in the air today.
I would agree, Lauren. And now to the fascinating discovery Liz Roche made in Hitchcock Hall.
Let's go to reporter in the field, shall we?
Hello, I'm Liz Roche, and today we found an AEV in the wild. I'm going to be very quiet, this is a very vicious animal. As you can see, this is an AEV. It has a nose like a helicopter, and it has 2 propellers and 2 motors. We want to be very quiet. It eats battery juice. When it hunts the batteries, that's really quite a sight. There are 2 different kinds of AEV cubs, as you can see here. This one is the male cub. It has a pointy nose and 1 propeller and it eats battery juice as well, but it only has 1 propeller and 1 motor. The female cub looks more like an aeroplane. It has a tail and it also has a shortened stem and 2 motors and 2 propellers. When the AEV evolves into an adult AEV, it looks just like this. Now we want to be quiet and don't disturb it or else it'll wake up and attack. It's a very vicious animal.
Wow, great work, Liz. In other news, I had the privilege to attend OSU's AEV Showcase yesterday and even got to interview 2 members of Group A.
This group truly showed what it means to be green engineers, didn't they, Lauren?
They really did. Let's go to that clip now. Hi, I'm Lauren Malone here on the scene of OSU's AEV Showcase, and I'm sitting here with 2 members of Group A, Chris P. Bacon and Seymour Butts. Why don't you guys tell us a little bit about your project?
All right, we were told to make an AEV. It's actually a green engineering project. Make a monorail kind of vehicle, and our goal was to limit the amount of energy used when we were going around the track. There was actually 3 stops on that track to make it a little bit more difficult for us, and I think we did pretty well with our AEV design.
All right. What were some of your team goals?
Our group goals were to listen to and consider each person's ideas, to be efficient and productive in labs and meetings, and to be open to changes and compromise.
Well, then let's take a look at your AEV.
All right. This is the physical design. Our actual code we had to use Arduino programming for.
Okay.
But for our AEV, we tried to make it as efficient as possible through making it as lightweight as possible, aerodynamic as possible, and as balanced as possible. And we did aerodynamics by attaching the front of this toy helicopter to the front of our AEV. And actually, it's kind of a funny story. Next was balance, and we used the AEV in the middle to keep it balanced with propellers on the back and battery in the front, which actually isn't present right now. It's charging.
Okay.
And as seen from this angle, we put the support arm just slightly to the side so it would be more balanced left to right. And as for lightweight, our design, we needed a shorter support arm, and we also used the lighter material. There was another heavier material, but we chose the lighter material just to make it as lightweight as possible.
Okay. Well, it looks like a lot of analysis was done in order to come to this final design.
A lot. And actually, our team member Anchovy is next to our presentation board, and she has that information.
Let's go take a look.
Hi, I'm Anchovy, and I'm going to tell you a little bit about our project. Our group name is
The Black Spider.
and here are some of the test results that we had for our project. The first graph you can see is thrust versus voltage for a 3-inch propeller, and it compares the thrust applied on the static test stand and in the wind tunnel. And then our next graph shows the propulsion characteristics and system efficiency. And our third graph shows the percent power to time for 3 different trials and determines trial 1 is the most efficient. This graph was really important because it helped us determine which code to use when making our project.
All right, Lauren, our Arduino code started usually with the acceleration, and then it would coast at a top speed for a while, and then decelerate, and power would go off, and it would coast to the stop. What we realized was that acceleration was using up a lot more power than we needed. In order to be as efficient as possible, we took out all the acceleration and deceleration into the coast, and just went with the straight, flat line, top speed. We eventually learned that our speed, it was a lower speed of about 25% power. We found that 30% power is actually even more efficient. And then we tried again with 35% and found out that it was a little too powerful. It was actually flying off the track at that point. So we ended up our final code as one constant motor speed of 30%. We used our code to stop at that point when we needed to. And eventually it would crawl to that stop and then wait 6 seconds or so and then go again.
Wow. Well, it seems like you guys did a great job with this project. Very impressed. And it'll be curious to see how well you guys do in your engineering careers. So thank you for talking to me today. Looks like the engineers at Ohio State are really making a difference and impacting the future.
They really are. I actually caught up with Group A to see how their AV performed on test day. Their results were outstanding. On their second trial, Group A's AV made it around every stop perfectly. And they say that they're very pleased with their performance, which scored a maximum amount of points.
Wow, that's really impressive.
It really is.
Well, that's all we have for you this morning, Columbus, but tune in this evening to see how Group A overcame the catastrophic event of their AEV flying off the test track. Wow, can't wait to see how Group A solved that one.
Well, from all of us here at OSU News, I'm Andrew Pavlovsky. And you stay classy, Columbus.
And thanks for stopping by.
But mainly, stay classy.
Thanks for stopping by.
Stay classy, I'm Andrew Pavlovsky.
And thanks for stopping by.
Stay classy.